Okay, so here is my notebook. I have pasted in the papers that I gave you today. So I started with the calculator instructions. Then I put in the histogram instructions. There they are. Then I put in types of data. Notice I wanted to point out there's basically two types of data, quantitative or qualitative. But within quantitative, and this is what we're going to be living in IB. Notice I didn't give you very much information about qualitative because we don't really deal with that in IB. We deal with quantitative because those are numbers, and we like to look at numbers. There's two types of qualitative data, discrete and continuous. So discrete is basically when you're counting. So like what's the average number of children in a family? You're going to have 2 children, 1 children, no children, 5 children, 10 children. You're not going to have 2.5 children. Okay, so there's discrete numbers that can be used. You're basically just counting. Continuous data, on the other hand, is when you are measuring, and so depending on how fine a measurement you do, you could have decimal places. So if I'm measuring how tall third graders are at Tamalpais Valley Elementary School, they could be anywhere between the shortest and the tallest. They're not going to be distinct numbers. They could be anywhere in between those numbers. So I'm not counting like individual objects. Instead, I'm measuring something. And so depending on the precision of your measuring tool, you could have any number of decimal places on that. Okay, so discrete is basically you can't have a number in between two numbers, and continuous means yes, you can have numbers in between two numbers. Okay, it can be broken up into smaller and smaller units. Discrete cannot be broken up into smaller and smaller units. Okay, so it's important to know the difference between discrete and continuous. That's really important in mathematics, understanding the difference between discrete and continuous. Okay, and then there are the shapes of distribution, bell-shaped, skewed, uniform, and bimodal. We're going to talk a lot more about skewed distribution and bell-shaped distributions. These are very important. And then just showing what a symmetric distribution means. So a symmetric distribution can be bimodal, it can be uniform, it could be, well, bell-shaped is also a symmetric distribution. Anytime you can take the center of your distribution and notice that one side is like a mirror image of the other, we say it's symmetric. Okay, so if we were to go back and look at this page, we can see that bell-shaped is pretty much symmetric. If I folded it in half, the two sides would pretty much match. So this might not be exactly symmetric, but it's pretty much symmetric, this one. There is something called the bell-shaped curve that is exactly symmetric, but we'll get to that later. This is not symmetric. Skewed distributions are not symmetric. Uniform, yes. Bimodal, yes. These are symmetric. So of these 4 examples, only the skewed distribution is not symmetric. But symmetric just means you could fold it in half and the two sides would match. Okay, and I think that's it. And then make sure you finish the worksheet from today, front and back, using your calculator. Practice figuring out where you put in the data into the, using the stat button, stat edit, and then finding the mean and the median by using stat calculate. Okay, so it's important to know where those buttons are. Get real familiar with them. All right, that's it. Bye-bye.